let's talk about functions first. We're saying that a function is polylogarithmic if it's a constant power of a logarithm of n. Now, we're not going to talk about those kinds of functions for a while, but of course we're going to mostly talk about polynomial functions. And a polynomial function is any function that's O of n to the power of a constant, like n cubed, n squared, whatever. An exponential function is, well, the next order up, 2 to the power of a polynomial function. And we're not going to talk about those quite yet either. Mostly we're concentrating on the word polynomial. Now, we're going to define the class of languages P. It's abbreviated P, but it's really P time, and usually abbreviated this way. And it's all the languages which can be decided by a machine, where the machine executes in polynomial time. In other words, polynomially many steps. Now, polynomial as a function of the size of the input. And that's always how we measure time complexity and space complexity. All right, and the next class we're going to talk about is NP time. Now, this stands for non-deterministic polynomial time. And we'll say that a language is in that class if it is accepted by a non-deterministic machine in polynomial time. Now, one question is, are these two classes different? This is usually abbreviated NP. And the question of whether these two classes are different is unknown. However, almost all the experts agree that they are probably different. I think they're different, but no one has ever been able to prove it. It's one of the big unsolved problems out there. You win $1 million if you solve it. But it's worth more than that. It's worth at least $1 billion, maybe $1 trillion. All right, now, another class we're going to eventually get to is the class P space. And this is the set of all languages which can be either decided or accepted with a machine that uses no more than polynomial memory. It can take any amount of time, even exponential time, but its memory can't be more than polynomial space. Now, how can you have so little space with more time? Well, you can constantly be erasing the memory as you go. So allowing the machine to reuse memory as it makes a calculation, saves something, erases it, does another calculation, and somehow takes any amount of time but does it in polynomial space. That's this class. Now, I wrote decided accepted here because it turns out that if I change the rule to decided or accepted, I don't get a different class. All right, so that's the definition of those classes cut. Now, as I've told you before, problems are the same as languages. That is to say, decision problems are the same as languages. So if I ask, what's the sum of the following two numbers? That's not a decision problem. But I can say, if I give three numbers, x, y, and z, I could say, is it true that x plus y is less than z? And that is a decision problem. Now, the traveling salesman problem illustrated here, the typical way to express it is that you have a weighted graph. The salesman wants to go around in a Hamiltonian cycle, meaning visiting every city once at the minimum cost. So each path costs money in some way. And I don't know whether this is the cheapest path, but this is a Hamiltonian path. Now, the traveling salesman problem, if I write it like, what's the cheapest path, that's not a decision problem. But if I say, is there a path that costs less than 20 or something, then that is a decision problem. And so that problem is in this set called NP complete. We'll get to that. Now let's say we have dynamic programming, which is something you should already know about. That problem is in the class P, or polynomial time. And every class of languages has...
Good.
Okay? So the factoring problem is given an integer, find the prime factors. Of course, that's not a decision problem, but you make it into a decision problem by asking whether it has a non-trivial factor less than a certain number, which is then a decision problem. And if you could solve that decision problem, you could then execute that solution a small number of times and figure out what the actual factors are. So it's equivalent. The dynamic programming problem would be then, is the solution no more than a certain amount? All right, now what I said was every class of languages has its co-class, or complementary class. And the complementary class of P is then, P is all the languages which can be decided in polynomial time, and co-P is the class of all languages which can be decided in, whose complements can be decided in polynomial time. But these are, of course, the same class. P equals co-P. NP is all the languages which are accepted by some non-deterministic machine with, in the best case, polynomially many steps. And its complementary class is co-NP, and if P is not equal to NP, then these two classes are not the same. So co-NP is out here, and